Today, we're going to dive into a really fascinating new strategy for upgrading our urban power grids. This comes from a proposal submitted to the U.S. Department of Energy, and it's called the Capacitive Mesh. And let me tell you, it offers a pretty radical new vision for how we power our cities.
So, our cities are changing, and they're changing fast. We're seeing this huge wave of high-demand technologies, right? Especially things like electric vehicle fleets. You know, an electric bus plugging in to charge creates this massive sudden spike in power demand. And that leads to the big question. Can our aging power grid actually handle this?
Well, this challenge creates what the proposal calls the urban grids paradox. It's this fundamental conflict that's right at the heart of trying to modernize our cities.
Okay, so here's the paradox in a nutshell. On one hand, you've got these dense cities with a massive and still growing need for way more power. But on the other hand, the way we've always done it, digging up streets to lay bigger cables, is just unbelievably expensive and disruptive. We're talking millions of dollars for a single mile. It's a total deadlock between what we need and what we can afford to do.
This diagram just shows it perfectly. This is the status quo. Our grids mostly rely on this radial design with exposed overhead wires. So when a huge load, like that EV bus plugs in, you get a dangerous peak and something called thermal shock, which pushes those old cables way past their limits. And of course, because they're overhead, the entire system is just a sitting duck for storm damage.
So, how do we break out of this deadlock? Well, this proposal introduces a really elegant solution, and it's called the capacitive mesh.
And this right here, this is the light bulb moment, the core insight that makes this whole thing work. Instead of spending a fortune digging new holes, you just use the ones that already exist. It's all about being smart with the infrastructure that's already under our feet.
Okay, now let's look at the other side of that diagram. See the difference? Instead of that sharp, dangerous power spike, the load is buffered, it's flattened out. The system uses what's called a smart node that sips power slowly from the grid, stores it up, and then delivers it in those high current bursts when needed. And look where the lines are running, through existing underground tunnels. No digging, no disrupting traffic. Now, the capacitive mesh isn't just one single piece of tech. It's a complete system, and it's built on 3 interconnected layers of innovation: hardware, a network, and software.
First up, the hardware. Out at the edge of the grid, you swap out the old transformers with these buffered smart nodes. The best way to think of them is like a shock absorber for the grid. When an electric bus needs a huge instant charge, the node's built-in energy buffer provides that power right away. Then, the node just gently recharges itself from the main grid at a slow, steady rate. That completely protects the old cables from that damaging thermal shock.
Next is the network layer, and this is where that clever quote really comes to life. It's called the dark conduit mesh. It uses high-voltage DC tie lines, but, and here's the key, they're threaded through the city's existing shadow infrastructure. We're talking about the tops of storm drains, old steam tunnels, unused pipes, all these hidden pathways. This creates a physical underground mesh network that connects different parts of the grid, all without the insane cost of trenching.
And finally, the software layer. This is the brains of the whole operation. It uses an established industry standard to create what's called a virtual power plant. So if one neighborhood suddenly has a huge power demand, the software automatically shares capacity from other less used parts of the grid. It shifts power through that dark conduit mesh in real time. It's all about maximizing the efficiency of every single asset you already have.
So, you put these 3 layers together, what do you actually get? Well, the benefits are pretty clear. It makes the grid smarter, way stronger, and a whole lot cheaper to upgrade.
Let's start with the money, because this is a big one. By not having to dig up the streets, this whole strategy cuts project costs by an estimated 80%. Now, this isn't just a small savings. This is what allows the upgrade to meet the Department of Energy's really strict requirement for less than a 10% increase in capital spending. The money goes into smart tech, not into repaving roads.
The system also gets a massive boost in resilience. Those local buffers and the smart nodes, they can provide ride-through power during a short outage. The underground lines are, naturally stormproof. And by connecting everything in a mesh, you get rid of the single points of failure that make our traditional grids so incredibly fragile.
It's also designed to be completely future-proof. So as the city's energy needs grow with more and more EVs, you don't have to start another massive construction project. You can actually increase capacity by just slotting larger battery blades into the existing smart nodes. The core infrastructure stays exactly where it is.
Now, this proposal isn't just a cool idea on paper, it actually lays out a very clear, actionable plan for how to build this feeder of the future.
The rollout is designed in 3 logical phases. First, you deploy the smart nodes. That tackles the most immediate problem of those burst loads from things like EV fleets. Second, you thread the tie lines through those dark conduits to physically create the mesh. And finally, you switch on the software, which turns the entire grid into this self-healing, intelligent system that's automatically balancing power all across the city.
So, we end with this thought. For decades, we've looked up at the sky, at all those vulnerable overhead wires, or we've faced the crippling cost of digging new trenches. This proposal suggests there's a third way. It asks us to look down, to see the hidden value in the infrastructure we already have. It makes you wonder, what if the solution isn't about brute force, but about being smart and strategic? What if the answer to our energy future is already buried right beneath our feet?